Hey everyone, so the title for today's notes is Solving Exponential Functions. Let's go ahead and go straight into it. So an exponential function, remember last time we talked about it, exponential functions are functions where the variable is in the exponent. So these are all exponential functions because if you look at the questions, the variables that we see are in the exponents. And you are expected to know how to solve an exponential equation. There are 3 basic steps that we're going to be following today, and the 3 of them are provided. So the first step says use the properties of exponents to simplify each side of the equation, which is why we needed to review those exponent rules last time in class. Step 2, you rewrite the equation so both sides have the same base. And then step 3, you drop the bases and set the exponents equal to each other, and then you would just solve that like a regular basic equation. All right, so let's go ahead and get started. Number 1 through 4 are considered the quote-unquote easy questions. Why? Because you're going to notice that all of these are equations already given to you with a common base. Here on like number 1, my base is 2, my base is 2. Exponent is x plus 1, exponent is 9. In number 2, my common bases are 5, and then I have my 2 exponents. In number 3, my common bases are 3, and then I have my exponents. And then in number 4, my common bases are 10, and then I have all my exponents. So these are considered the quote-unquote easy questions because as step 2 says, you have to rewrite the equations so that both sides have the same base. In numbers 1 through 4, same base is already given to you. The more challenging ones are numbers 5 through, 20? Because 5 through 20, if you notice here, the both sides of the equations do not have a common base. So your job is to get a common base. All right, so I will start off with 1 through 4. I am not going to be doing all these questions today. I will probably be choosing like 4 or 5, and then the rest you will be expected to do in class the next time that I see you, which would be on Thursday, tomorrow. Okay. So let's go into it. Number 1, we'll do number 1, and then I'll probably do like number 4 as well. All right, let's start off with number 1. So step 1, it says to use the properties of exponents to simplify each side of the equation. If you look at each side of the equation, I have x plus 1 and 9. There is nothing to simplify there. Examples like number 3 and 4 would be ones that we have to simplify because like we would need to combine these two. Over here, we would need to combine these two. Over here, we would need to combine these two. So number 1 is the easy one. Everything is already simplified. Both sides have the same base. The common base is 2. So all you have to do is just drop the bases and set the exponents equal to each other. So we just set x plus 1 is equal to 9 equal to each other. You solve this. The value for x is 8. And that's it. And you can always check your answer. You can substitute in 8 for x right there. So that would be 8 plus 1. Does 2 to the 9th equal 2 to the 9th? Well, it indeed does. So you know that that solution works. All right, I will go ahead and do one other one for you, like number 4. Number 4, you should notice here that you first need to simplify down this side and this side to just have like a single term is equal to another term. And how do you simplify? Well, using your exponent rules. They do have, these 2 terms have the same base, so, and they're being multiplied together. So using your exponent rules, 2 terms, same base being multiplied. What do you do with the exponents? You go ahead and add them. So this would be 10 to the power of 4 plus 9 is, negative 4 plus 9 is 5. Equal to, on the other side, we have 2 terms, same base being multiplied together. So we need to add our exponents. So this would be 10 to the base of, 10 to the power of, well, I have v plus 4 plus 2v minus 11. So this is essentially v plus 4 plus 2v minus 11. Why are we adding them? Because again, your exponent rules tell you 2 terms, same base being multiplied, you add the exponents. So what would this simplify down to? 10 to the 5th is equal to 10 to the, we can obviously tell here that I meant to do highlighter. That v can be combined with 2v, and then 4 can be combined with negative 11. So that would go ahead and give us 3v minus 7. And then now you can go ahead and now you should notice that both sides go ahead and have the same base. They are simplified, so you can drop the bases and just set the exponents equal to each other to solve. So you would be setting 5 equal to 3v minus 7. Go ahead and move that 7 over, so this should turn to 12 is equal to 3v, and then you divide both sides by 3, so you get v is equal to 4. So my value of v there is 4. Again, you can substitute in v back into your original right here, and then you should get two sides that are equal to one another. All right, those are the first sets of questions. On those, obviously, both sides already have the same base, so they're considered the easier ones. Let's go ahead and go on to the little bit more difficult ones, where you're going to have to do one extra step to get a common base on both sides. From these, I'll go ahead and probably pick like 2, and then on the back side, I'll pick like 2. The rest you will be expected to do on Thursday in class. So let's look at number 5. So obviously in number 5, one of my bases is 6. The other base is 36. Even though I do not see an exponent with 36, remember it has like an imaginary exponent of 1. So that is indeed a term there. It's a constant term, but it does have an exponent of 1. Now, both sides of this equation, though, since that common base is not given, you need to go ahead and do some work to get a common base. And how do you do that? Well, you need to ask yourself, is there a way that I can represent 6 and 36 with a common base? You should realize here that the number 36 is equivalent to 6 squared. Because remember, 6 squared is equal to 6 times 6, which is indeed 36. So 36 is equal to 6 squared. So I'm going to go ahead and replace 36 with 6 squared. I'm going to bring down my other side of my equation. And then now, ta-da, there you go. Two bases that are the same, so I can drop my bases and set my exponents equal to each other to solve. You do a little algebra, you should get 2x is equal to 12, divide both sides by 2, and then you should get x is equal to 6. All right, and then just FYI, for these questions, all of them, you will be able to rewrite them to get a common base. Eventually, in this unit, we will get to times when you can't represent the two numbers as a common base, and then there's a different process you need to use. But for this homework assignment, you should all be able to always represent the numbers as like a power of another number to give you the given value you're looking for. All right, let me do another one. Let me see here. I'll do number 7 because I feel like because everyone sees the fraction in number 7, they get a little bit confused. Obviously, both of these sides do not have a same base. This has a base of 7. This has a base of 1 over 7. You need to remember, though, from your exponent rules that 7 to the power of negative 1 is actually equivalent to 1 over 7. Why is that? Because remember, in order to make a negative exponent positive, you need to move it to the denominator. So these two would be equivalent to one another. So to rewrite it, you would have 7 to the 4x plus 11 is equal to 7 to the negative 1. Now you have both sides having equivalent bases, so you can drop those bases and just set the exponents equal to one another and solve. You end up getting 4x is equal to negative 12, so x is equivalent to negative 3. Again, you can always substitute that in to verify that it's true. All right, hopefully you all are good with this first front page. If you have any questions, go ahead and write them off to the side and then ask me next time you see me. I'm going to go ahead and do 2 from the back, and then the other questions you are expected to work on for classwork on Thursday. Actually, yeah, classwork on Thursday. All right, on the back side, I'm going to go ahead and pick two that I think are probably the most difficult to do. So, let's see here. Let's, for example, let's just start at the top. Let's look at number 11. So in number 11, obviously both sides of this equation do not have a common base. I have a base of 125 and I have a base of 25. Now, is there a way that you can represent both of these numbers with a common base? You should be realizing here that, well, can I represent 125? Can I represent 125 with a base of 25? Not really, because 25 to the second power, that's already going to be a super, super, super big number. Remember, this is equivalent to 25 times 25, and 25 times 25 is equal to 625. So obviously I'm not going to be able to represent 125 with a base of 25, but you can represent both of these numbers with something smaller. And what is that smaller base that both of these numbers can be represented by? You hopefully are telling yourself 5. So you can replace the 125 with, go ahead and put this as 5 cubed. And all I'm doing is I'm just putting 5 cubed in for only 125, right? And then you just carry over the other exponent that was originally given to you, which in this case would be y. On the other side, how can you represent 25 with the base of 5? Well, that one would be 5 squared. And then now on the left-hand side, you need to use your exponent rules. You have a power to a power. What do you do when you have a power to a power? Remember, you need to multiply. Now you do not add. Now you multiply. So this will give you 5 to the 3y is equal to 5 squared. And then now these are like the questions on the front. Two bases, they are the same, set equal to each other, so we can drop the bases and set the exponents equal to one another, which will give you y is equal to 2 over 3. All right, I'll do one more back here, and then hopefully you guys are good. Which one should I do? Let's go ahead and do number 20. I feel like because, again, you see the fraction and you see maybe like the two terms, this one might look a little tricky. So obviously, actually, no, not number 20. That one's a little easy. Maybe. I don't know. I want one that I have to rewrite both of them. Let's see here. Maybe 16. Let's do 16. So 16, your two bases are 27 and 243. Obviously, those are not a common base. Is there a way you can represent 243 with a base of 27? If you try to do that, it wouldn't work. So this is another situation where you have to rewrite both bases. Now, what is a common base that both 27 and 243 can be rewritten as? Guys, I mean, some of you guys might see it right from the start. Others of you might not. I would just always start small and make your way up. Like, start off with 2. Is there any exponent that you can raise 2? Like, is there a number that you can put up here? Sorry, I don't want to make that look like a 0, but like a number that you can put up there that's ever going to give you 27? Obviously not. So then I would just try like the next number, which would obviously be 3. Is there a number that you can raise 3 to that should give you 27? You should be able to tell yourself that in that case, that x value would be 3, because 3 to the third is 27. So you can go ahead and replace 27 with 3 to the third, and then just copy over your 2x equal. On 243, you'll realize that that can also be represented with the base of 3. So this will be 3 to the 5th, though, raised to the power of x minus 2. Remember, you're adding these new exponents, but you still need to copy over the original ones. And then here you have a power to a power, so you have to multiply. So this will turn to 3 to the power of 6x is equal to 3 to the power of here. Be careful, this needs to be distributed to the x and to the minus 2. So this will turn to 5x minus 10. Now you go ahead and have your two terms. I keep on saying two terms. I'm sorry. Your two bases that are the same, set equal to each other. So you can drop the bases and set the exponents equal to each other and solve. Go ahead and get your x's to one side of the equation. You'll end up getting x is equal to negative 10. All right, hopefully that was enough. If I need to do more, ask me in class on Thursday. Yeah, I think what's most difficult is maybe just, I would assume maybe like this part, like knowing how to represent these numbers with terms that have the same base and with different exponents. All right, let me know if you have any questions. Number 14, like I'm just looking at it right now. You guys might have questions on it. Again, if you see anything with a fraction, go ahead and just put that, change that to 3 to the negative 1. That'll get rid of that fraction, and then that's how you eliminate that. So you can think of that as 3 to the negative 1 2x. Same thing over here. Think of this as like 81 to the power of negative 1, and then just bring down the rest of your equation, the 9 2x plus 14 times 9 2x equals, and then you should be able to think about it here. How can I get a common base between 9, 9, and 81? So those fractions, don't let them confuse you. Just change them to the power of negative 1. Alrighty. Let me know if you have any questions.